We're going to do a little exercise now where we're going to actually use what we've done so far with safe starts. Okay, the agenda for today is we're going to make a little sample plant graphic for area 1. We're going to then develop a start sequence, and then we're going to try and tie that into the safe start by creating a little UDT for a motor, and then the DB for it, and then same for a valve. And then we're going to go into the safe start function that we created, and we're going to expand it to include those sections. Okay, let's go to Window Maker, and I'm going to open up area 1 in the navigator, and the title bar. And just a quick note at the top of the screen, this little icon here will allow you to see what it will look like if you were running, and we can even hide the title bar. So let's go to properties, and we go auto hide. So now you can see that's what your graphic will look like. So if you just click back on this, it will come back to where you were. All right, so let me go back there. All right, so what I want to do now is I want to just explain a little bit more. We've spoken about real estate of the screen. We've taken away some of the real estate with the navigation bar. I know it's a big one, but anyway, and the title bar. So now we've left with this part of the screen. But just a note, you can't go and put this rectangle right on the edge here. It just looks a bit stupid. You can't put this, if this was a tank, you can't put that right there. You've got to allow space just to make it more readable. So I just suggest that you just leave a border of say 5 or 10 around again, and then again, you don't want that stuck to the left-hand corner. You sort of want it to be sort of in the middle of the left and the middle of the right. So we want to be able to divide the screen into some useful areas. Okay, so what I do is I normally put some construction lines on. If you've ever done drawing in a course, they talk about construction lines. So I'm literally going to go back to my horizontal vertical line icon here, and I'm going to put a line down here, and it doesn't have to be that dramatic, but it should be sort of quite close to the edge. If we remember, this area 1 graphic is 628 high. So if we start at the 0 of this graphic, remember down here it's at 7 now, the Y. So if I go up to 0, I can make it, what was it again? 628. So I can make this line 628, and you just drag it down, use your arrow keys. You can see I can't do that, so I'm just going to move it up a bit, and I'm going to make it 628 exactly. See, it's at -14 now. So if I now just go shift and down, it's at -4. Now it's perfectly full length of screen. It's at 28. So let me move it to the left, say to 20. All right, so that's a construction line. I'm going to even change the color of it. Where's line color? There it is. Make it a red line. And I'm going to also just make the visibility of this 0. So what this functionality does, whenever this expression solves to true, it will be visible. So 0 will never be true. Okay, so there's my construction line. So now that is 20 from the left-hand side. If I press Control D, I can literally go up 2 with the Shift key, and I go all the way to the right-hand side. 1024 minus 20 would be 1004. So that literally will then, see it says 1004 here. So I'm not going to try and draw in this border. So I've got a construction line for that side. And now what I want to do, let's say I want to divide the screen into half. So I literally can, again, copy this line, Control D. I can then hold the Shift key in and highlight that one. and I can highlight that one. So I've got all three selected. You can't really see it. But if I now go and I say space horizontally, bang, it's now I go line to top. That line should technically be right in the middle. You can see 512. So now I know that's the center line. So if I put a title over here, so I want to say area 01, I can then center that text. Where is my center button? There it is. I can see it's not exactly in the center. So if I move it with my keys, it's something like that. And then I can make it nice and centered. And I can even make it, let's go to a standard font, make it bold, make it 16. There's area 1. Doesn't look the best, but anyway, there we go. Now I've got a title bar. Title, and it's centered because it's on my center line. If I want to now have another area here, the easiest way to do is do a Control D there. Another one, just so I've got now, got 1, 2, 3, 4. And if I go to this one, I've got 5 lines. If I do this align space horizontally, they're all now equal. If I go just up, now I can see I've got a center line. And I've got, so now I can put this tank, if it was, I can literally try and align it over there. And I can align this one over there. Or I can put it sort of in the middle of this area, and I can put this one in the middle of this area. I could then have an elevator or something over here, another tank, another bin, so you can align it. So that's just generally what I do to lay out the graphic. And I'm going to just put a construction line at the top here too. I'm going to put it under this area, so let me just put it somewhere there. I'm going to move it up, and if I just go back, it hasn't got a visibility. Okay, just remember, when I duplicated those lines, they all kept their visibility, so I don't have to go and do that. So this one I've done. I want to make this 1024 long, but I want to start at 0. So press Control, it goes quicker. I'm just going to make this 1024. Watch the bottom there. There it's 1024. Oh, that was clever. It's at -19. So if I go, there it is. It's perfect. If I go up one, it's at 030. So I don't draw in that top part there. And now, if I duplicate that line and I duplicate it again, and I just move this one down, and I know it looks silly, but I'm going to go here. And remember, this graphic was 628 high, so and that one was 30 in. So let's make this only 20. So 628 minus 20 is 608. So now that line is at the bottom. It's not technically at 0. There it is. It's at 0, 608. So now I can highlight that line and that line, select them, and I can space vertically. And now I've got a center line. So now I can plan my graphic. Make sense? So now you can make sure that your graphics have a certain layout, and they don't look all cramped to the one side. You don't put this thing over there. Put it all nice and centered, and you can put labels around it. It looks reasonably neat. That's what I would do. Okay. So if I save this, area 1, okay, so let's say I want to use that as my template. All I'm going to do is I'm going to save this file, save window as, and I'm going to click on that one. And I'm going to say this is my template. Okay. So now I can close templates, and I can open area 1 again. Oops. Area 1, I can delete that, and I can delete that, and everything's fine. So now I'm basically, let me go and open my template again. I want to also take those tanks over there, or those rectangles, save that one, close my template. I am on area 1 now. And now what I want to do is I want to draw a little sample graphic. So I've actually done it. So, okay, as an exercise, if you were to go to the symbol factory, you can start to use some of the inbuilt symbols of Wonderware. And they've got a whole range of things. So if I was going to draw a tank, where are tanks? There's a tank. I can draw a nice fancy tank here. So let's choose this one. Oh yeah, okay, let me choose that one. Say, okay, there's a tank. You can drag it. You can. It looks. These are not the best symbols. I'm not going to lie to you. If you double click them, if you just go to options, you can take off the X and Y so that it zooms together, so that it zooms properly. And now you can make it longer and bigger, but it starts to look a bit gaudy. After you've done this for a while, you're going to draw your own symbols, but these are good examples for things. Let me go back. I'm going to choose a symbol again. I'm going to put, let me go to pumps. So I can put one of these pumps on. And there it goes. And even they've allowed you to do some animation, and they've grouped it and done things so not everything works, but it's a symbol and it'll work for you. But if you want to design proper features, you need to break that up. See, it says break cell here. And now I can start to take that off as well. Now I can start to break this apart and draw what I want to do there. But that's for another day. You guys can play with symbols. Okay, so what I've done is I've already drawn a little sample graphic. So I'm going to open this little area 01B graphic, and I'm going to just copy this little sample part of graphic here. And I've purposely put on a motor for the agitator. I'm just going to copy and go to area 1, and I'm going to paste it in here. And I'm going to try and, okay, it's not bad. There we go. Does that look okay? So it's pretty much centered in this half, and this is okay. I could move this around, but anyway. So I put a pump from the symbol library there, I put a valve from the symbol library, and an agitator motor. So here's a simple process that we want to, say, run. And the idea is that there would be some product in here, either liquid or let's say it's a liquid, let's say it's some very very sticky product, and you want to pump it across to this tank, and it'll have an agitator on it, and you will probably put some water in there, and you will mix it, and then obviously the next process will take care of that. So we have a motor. We have two motors we need to start in this sequence, and we have two valves. The concept that I've built is that you would start the agitator, you would then close the drain valve first, you would open the supply valve, and then you start the pump, and then it would pump product. So that would be a simple start sequence. Okay, so now I can save my area 1 graphic, and now I have it. So if I literally go to runtime, there's our graphic, area 1, and we have our title bar, and we can still go to area 2, area 1, all these buttons still work, but we now want to concentrate on the sequence. So I'm going to just quickly go back to our agenda. Okay, so we've done a simple graphic. There it is. As I say, there's an agitator and two pumps, a pump and two valves. So this would be a typical start sequence. Okay. So this is what I'll do. So on the graphic, we'll put a button to say sequence start. The PLC program would then, this is another tip, don't go and make your step numbers 0, 1, 2, 3, 4, 5, etc. Because one day you're going to want to put a step in between here. And now you're going to have to reorder all of those steps. So just start at 10, say, or start at 100 like I have there. So you might want to do some special checks before you even can start the sequence. Here I've got all conditions okay. I'll go back to my graphic quickly. Maybe we're going to check that this tank is not full. This tank has got product in. Some things are on trip, say, and so on. So maybe this one must be empty because it's a different brand. So all of those checks you're going to do in your pre-checks. And then once they are all cleared, then you say start the agitator. Now remember, the start is going to go to our safe start circuit, give it a safe start request. It's going to put the siren on. It's then going to come back after the siren, and in the safe start period, it will start that motor. And then once it's running, it will then go to the next step to open the supply valve. Okay, I did it differently. When that valve is open, close the drain valve. When that valve is closed, actually start the supply pump. And then once motor 2 is running, the sequence is running. And that is a simple sequence. So start the agitator, open the supply valve, close the drain valve, start the motor, start the pump. All right. So let us now try and first of all, we need to create a UDT, the second best thing since sliced bread, or third best thing after a USB stick, is to create a UDT, user-defined object for a motor. So we want to typically have in the UDT, the actual motor outputs, in the UDT, the run feedback, a fault status, a start and a stop bit, and a fault timer, and preset and actual. So let's go and create that preset, that UDT. So now we're going to go to here. I'm going to go insert new object, data type, and I'm going to call this UDT 50. The method in my madness, I'll just call that UDT motors. There it is. Open it. And now we're going to do exactly that. So we're going to put in here a MO, which is going to be a bool, and that is motor outputs. We're going to have RN for a bool, and that is the run feedback. We said fault, which is also bool, fault. But we had a start, and a stop, and we had a FTP, which is going to be an integer, remember, and that is the fault timer preset, and an FTA, which is also an int, fault timer actual. Right, so our UDT is 6 long. We should technically, like my practice, put in some dummy stuff here. So I'm just going to put in X, which is an int. Now it's 8, put in Y, int. And now it's a nice boundary of 10. So if I save that, I've got a UDT, accept the prompt. So now if I go back and I want to now create a DB for this, 50 makes my DB. I'm going to insert a new data block. It's going to be DB50, and then is DB motors. Okay, just a little point. You see I put DB dot something and UDT dot. This is a naming convention which comes from a lot of programming styles where you try and in the front put the type, even though you know it's a DB. You put in there, so wherever you are, you know straight away what type of variable you're looking at. Yeah, we could get pedantic and say this is a bit, so B or something, or bool, but you know, that becomes very laborious. So we don't want to do too fancy, but anyway, that's a point. Right, so we've got a DB50. So I'm going to remember, let me go back to my graphic. We have a motor 1 and a motor 2. So just for simplicity, I'm going to put motor 1, and that's going to be UDT50. This is just the initial value. UDT has got its own initial values, and that's motor 01, agitator, motor 02, UDT50, supply. Now, you can see it's all nicely on borders, but it would just be very useful, to allow for expansion. So if you press enter there, it gives you a new line. So I'm going to make a motor 0, motor 3, I mean, I'm going to go here and make a motor 4, and let's say I make a motor 5. So now I've got 5 motors, some for the future. Save it. I'm going to now, so that's my motor. And now we can use, so if I open this up, remember, the view, this is declaration view. I go to data. There are all the bits for the motor and for each motor, and we have everything done. So that's perfect for the motor. If I go back here, we've created the UDT and we've created a DV for it. Okay, so the next one we want to create for those two valves, we also create a UDT. So now this one's a little bit more complicated. We're going to assume that these valves have got limit switches on them, so it's going to have an output to open it, and when it gets to the limit, it will switch the output off, or maybe it'll keep it on. And I'll have an output to close it, and I'll have a limit to say that it's closed. You want to, especially in this instance, this valve, you would just, my thinking, you would want to have confirmation that it is closed. Open doesn't matter, but if it's not closed, you know it's got a path through it. And this one is a different one. You would want to make sure that the drain valve is closed, so you don't pump everything to drain. So then if it's not closed, it would technically be open. But yes, let's put both limits on. And so we're going to go back to this. We're going to create the two outputs, valve output to open, valve output to close, fault bit like before, command to open, command to close, and the fault timer again. So let's go back to Siemens here, and I'm going to create a new data type, and I'm going to call this UDT60, and it's UDT for a valve, valves. And if I open it up, I have the same thing, so I'm going to put valve open output. It's a bool, and it's valve open output and valve close output. Valve close output. LSO bool limit switch closed. LSC limit switch R close. I made it wrong. Let's go up here. Open fault bool fault. Okay, command open. I'm just going to say open. That's a bool as well. Open command. Close. Close command. And then we want a FTP again. Fault timer preset. I just did a copy paste copy there because I'm going to just be lazy. Okay. You see it's also 6 long, so I'm going to do the same I did for the drive. I'm going to put an X here as an int and a Y as an int, and now it's a nice round number of 10. Save it. It's going to tell me it's changed. That's fine. Go back here. Now I'm going to create a DB exactly the same way. Create a data block, DB60, DB valves. Okay, so now I want valve 01, and that's going to be UDT60. Right, so there we have our DB. It's got some nice, it's all nicely on board of 10. Save it. I can close all of these things, go back to Siemens here, and I'm going to go to my simulator. And then I'm going to go and download it. Let me check my, yep, it's on MPI. Right, so I'm going to go and download it. There it is. go back to my simulator quickly and run it. And there my simulator is running. Okay, so now let's go back here. So we created the valve UDT, like we say. We're now going to go to our safe start. And if you remember before, we had created the UDT, and we had also created, there's the UDT for the safe start. And we had also created our function block, group start. Okay, there it is. There's the e-stop, there's the reset timer, there's the siren timer circuit, which sets the safe start period. There's the safe start timer, and there's the safe start, end of safe start, which resets the siren, well, resets this, well, sorry, resets the safe start, which allows the safe start request to put the siren on again. So now, what are we going to do? We're going to add some circuits to this. We're going to create a circuit for when either motor 1 or motor 2 requires a safe start request. So I go down to the bottom here, I do it, I go, I just press F. So now I want db50.motor01.start. That didn't work. So go here, db, go to motors, motor 01, and I want to start. There it is, motors 01. And I want to have not running of the same motor. So I'm just going to click that and copy it. And I'm going to just change this to the run. Yeah, motor start and not running. I want to put on my safe start request. Okay, and then I want to do the same for motor 2. So I can literally do that. Right. Copy. Close that. I can change that to 2. And I can close that to 2. I can change that to 2. And there's our safe start request. Okay. So you can see this logic will always put this coil on, the safe start request, if we either have a motor 1 start request, and it's not running, a motor 2 not running. So it will keep on activating this circuit, which will put the siren on, then the safe start, and it'll keep on going until they both are running. Remember the last time I said you need to have some sort of mechanism that if this doesn't happen after a time, it might reset the whole sequence and switch those starts off. But that's for another day. Okay. So now we want to remember we built in the session before, we built a warning circuit and an alarm circuit. So remember we have now created a fault bit for this one, for the motors and for the valves. So technically what we might want to do is we might want to say that if the drain valve has a fault, it is a warning, may not be an alarm. So we can go to DB, we're going to go to valves. I'm just giving an example, and the drain valve is valve 2. Oops. And we want to make that the warning. So remember, it's group grp.war. So that will give us a warning. And all the other, the 2 motors and the valve 1 will give us a fault, an alarm, sorry. So if I make that valve 1, and if I just copy that, I'm just going to, and all of fault on motor 1, and I'll do the same, I'll copy that, change that to 2, 9, and we want to cause that to be the alarm. Oh, must be a group.alarm. Okay, so that is alarm. So now we actually have, the alarm will come on. If I go back to my graphic, it will technically control those 2 bits, although those are memory bits at the moment. When we change the tie them to the PLC, they will be tied to those two states, and obviously they will cause the boundary, the border of the button to show a red line when it's in warning, and it'll flash when we have an alarm. All right, so now we also want to determine when that group is running and when it is stopped. So let's go back. So when it'll be running, this will be running, this will be running, this will be closed, and that'll be open. When it's stopped, literally that will be not running, that will be closed, that'll be open, and that will be stopped. So let's go and do that circuit. So if I go like this and I say motor 1 running, I'm just literally going to copy and paste, motor 1 running, motor 2 running, and I want valve 1. Let me go back again. Valve 1 must be open. So I want the LSO, limit switch open, and I want valve 2 to be closed. Right, and then I want that to say group.group run. That will be group running. And then I can literally copy this one and say group stopped. What is group stopped? Almost literally the reverse. This one will be a normally closed. So you can't do that. Just put a normally closed next to it. You copy it and you delete that one. And then we copy this one and we copy that to there. Delete that. And we want the LSC of this. And we want the LSO of that. And that will be group stop. Right, so there we have completed our safe starts function. We have the e-stop, the reset timer, the safe start siren, the safe start period, and then we have the safe start request, the warning, the alarm, the group run, and the group stop. And we just save that and we download it. If I just literally run it, can't highlight everything. Okay, that's fine. If I go to here's my safe start request, I don't have a start. If I created a start, see the safe start is on, and now, oops, where was I? Safe start's on. There's the siren, and now it's on the safe start period, and it's counting out, and it will carry on until I get a run feedback, and that will be controlled by a motor, by the drive circuit, and there the safe start request has gone off. But if in the same time I create a start on motor 2, it will then start that until motor 2 is running, put the safe start request off, and everything's fine. Okay, so that is all of those functions that we've done there. Very simple little lesson today, or session. We have in the start sequence, just for you to think about, what would happen, like literally this sequence now. What is going to happen the moment this motor starts? Technically, the moment the output comes on, within milliseconds, the contactor will close and we'll get a run feedback. The valve will open. Okay, this one is nice because the valve will take a second or two to open. And this one, then we'll start the motor. Say the safe start period is still active, so this motor will start. But if you literally started, say, 10 motors, one after the other, what's going to happen within milliseconds, you're going to have all of them starting under full load current. Full load current, the starting current of the motor is typically 6 times full load current. So you literally have 6 times full load current to all those motors, and you could blow up your main incomer, or you could trip it, and you literally will never get your plant to start. So as I say, what about the startup current of the motor? It's typically 6 times the full load current of the motor.
Happy Father's Day, Daddy.
Thank you, thank you.
I hope that you have a lovely Father's Day.
Okay.
I'll treat you later.
Why?
It's always to get paid.
Okay. It's fine. You've been out for so long. So we talk about the startup currents, and yes, we'll probably trip the main incomer. So what I want you to think for yourself, how would you create a time delay between the motors starting in the sequence? Would you do it in the motor circuit or in the motor drive block, or would you do it in the sequence? What can go wrong with the start of a motor? What is the logic for the fault bit? We made a very simple UDT with a motor and a run feedback. How would you know that the motor is faulty? Can you think of any other functionality that you might want to have in the motor UDT? Again, the valves themselves also, do they need time delays between one valve opening and the other one closing? How would you program those time delays? Would you do it in the valve function block, or would you do it in the sequence circuit, a sequence logic? What can go wrong with a valve? You see we've now created a valve with 2 outputs and 2 inputs. So just to give you a hint, let's say the valve is closed, you know it's closed because we have a limit, and you put the open output on. First of all, it may not even move off the closed limit, and it may not even get to the open limit. So that's 2 faults. And again, what happens when the valve is open? You know it's open, you have the limit switch, and you put the close output on. Does it move off the open limit, and does it make the close limit? So that's 4 faults straight away. So how would you program those 4 faults, and what sort of time delay would you give the valve to achieve the limit or move off a limit? Can you think of any other functionality that you would want in the valve, in the UDT of the valve? Right, just how would you program the sequence? You can see, if I just go back to our sequence, that sequence is drawn like there's a programming language called GraphSet or SFC, sequence flow chart. If you program GraphSet in the Siemens, you need to load another package, which costs money, but that's beside the point. There are a lot of PLCs with GraphSet or SFC built in. If you haven't experienced it, maybe you want to play with that. And if you don't have GraphSet, how would you program that? That's just a good test for today. And then let's go back to our graphic. We know we've literally started this sequence up. Like we said, what are the preconditions? What can happen if this agitator is started when the tank is full or half full? What will happen to the starter current of that motor? Do we need to make that motor have a star delta starter, or does it need to have a soft starter? And then how do you allow for the run feedback in that instance to be delayed by 30 seconds to maybe 60 seconds? Again, sorry, I digress. What happens if this tank goes full? We don't have a high level. So this motor will just carry on pumping, and hopefully the tank's got a overflow valve, overflow pipe. But if it doesn't, you're actually pumping now into a closed tank. What's going to happen to this pump? It's either going to start to cavitate. It could start to pressurize the line. You have a whole lot of issues. How do you know, again, how do you know that the actual fluid we have in here, which I said might be sticky, is actually flowing? You might need to have a flow switch. Is it now a high flow switch or a low flow switch? Do you need a flow indicator? Do you need a pressure indicator? Do you need to have some sort of cleaning on the pump? They talk about a gland valve in the mining industry with all the slurry they have. And what about this tank? Does it need a low level? Do you, when you start, do you need to confirm that there's product in here and there's nothing in there? You need a low level and a high level. Do you need a level transmitter? There are a lot of extra instrumentation that you could add to this plant to A, protect the plant, and B, to make the control of it much easier. Maybe you want a PID valve here so that it controls the flow. There are lots of options, but that is just one little plant, and look at all the options we could have. What other things could you think of? So you can go and start to program your sequence. You can go and start to think of how to program the fault in a drive function block, and so on. What other functionality? And there we go. That is what we have.